Hey guys, how you doing? It's Coach Scott with Purple Waves Chemistry again, and let's get started on Unit 6, which is intermolecular forces. So let's go back and let's start talking about what matter is, all right, and how does matter act in life, right? So anyway, let's do it. So when we see matter, right, we know that atoms are those small particles that are the basic units of stuff or matter. That's another name for matter, stuff. So when we go to the nanoscale, we know that they're bound, they do bond together and they'll create compounds due to what? Coulomb's law, electrostatic attractions, and electronegativity, right? So these chemical compounds will react with each other also, breaking and reforming bonds to make new chemical compounds. So, look at water. If it's just water, it'll be constantly going back and forth between the hydronium ion and the hydroxide ion. All right? Whatever water there is, there's always made up of hydronium and hydroxide ions. We'll get to that when we start talking about acids and bases later. So, we know that atoms and molecules are very tiny and very small. So, we can't actually see the substance unless it's made up of many, many particles, right? So, we know that 1 milliliter of water at 4 degrees Celsius is equal to 1 gram of water. Why? Because of the density. So, 1 gram of water, right, 1 milliliter, has 3.34 times 10 to the 22 molecules of water. So, what makes these water molecules stick together, all right, to make a large enough amount that we can actually see and touch and do things with? So think about what we've learned so far in the first part of the year. We explained that particles, atoms, and elements, and we understood now how they build up the periodic table from quantum numbers and some from subparticles. We understand a little bit about quantum numbers, S's, P's, D's, and F's. Atomic numbers, atomic masses, relative atomic masses, things we've touched on and explored. Then we talked about how atoms can combine to form molecules, right? And formula units and ionic compounds, right? So most of the way we see these things, these atoms are found in nature as molecules. And we learned how these atoms from molecules will rearrange in chemical reactions to form new chemical compounds. We talked a little bit about that. So now we're going to use intermolecular forces that happen between the molecules to create what we know as the states of matter. Intermolecular forces are the piece, the key that we need to put the puzzle together to explain why do we look like what we do? Why is our desk hard? Why does water wet? Why is water a liquid at normal state, at STP? So without these intermolecular forces, we couldn't have tables or lakes or walls or even our own bodies. We'd just be little bits of slime. So intermolecular forces shape our world. So there are many states of matter, but the three most common ones, and these are what dominates our world, are gases, liquids, and solids. We're not going to get into some weird stuff like plasmas and nuclear matter. We're not going there, all right? So there are two fundamental differences between states of matter, and they are the distance between the particles and the particles' freedom to move. All right. So the states of matter we talked about are gases, liquids, and solids. Gases, particles are so very far apart. They've got total freedom. They can go wherever they want. They've got so much empty space, there's total disorder. Now, if we heat or decrease the pressure on liquid, we have gas. If we cool a gas or we increase the pressure, then it can form as a liquid. Well, a liquid, there's disorder, right? There's still freedom to move, all right, relative to each other, but they're pretty close together, Okay? Now, a solid has got an ordered arrangement. The particles are in fixed position, and they're very close together, right? So we'll watch a video in class about these the different states, but let's move on, right? So let's talk about what makes a gas, the shape. It will always assume the shape of its container. The volume will expand to the volume of its container, right? And the compression, it is very compressible. That's why we have pneumatic lifts, all right? It flows very easily, and the diffusion is very, very, very rapid. Right. So a liquid, it will assume the shape of the container of the part that it occupies. Right. And the volume, it will not expand to the volume of the container. It's virtually incompressible. It can compress a little bit. It flows very easily, right? And the diffusion is a little slower than gas. Now, solid, it will retain its own shape regardless of what container you put it in. And the volume, it will only be the volume of that solid. It will not expand to the volume of the container. It's virtually incompressible. It will not flow, a pure solid. And it will not diffuse. It's got a very, very, very slow rate. All right? So, as these particles are closer together, these are what we call the condensed state. All right? A liquid is slightly condensed from the gas. A crystalline is very condensed. So a liquid and a crystalline solid are your condensed states because they're so close together. Okay. We got some questions. I'm going to pause right now. And that's what we need to know about states of matter. Hopefully these are just a refresher course you've already talked about in other science classes. So this is Coach Scott saying, have a great day and hullabaloo, knick, knick.